All right, so I'd like to welcome you all to our final data science and community seminar, which I'm really proud to say is co-hosted today with the Data Then and Now seminar. We have a really fantastic speaker lined up for us. We will be using the Q&A feature of the webinar. So in the middle bottom right of your Zoom screen, you will see a Q&A button, and you can click on that, and that's where you can ask questions. We'll probably answer those questions at the end. So please feel free to ask them whenever you want, but that's probably where we'll address those. And again, speaking for the data science seminar and the community seminar, this is our last seminar of the year. And I look forward to you joining us again in the fall when we start again. Without further ado, I'd like to introduce Megan Finn, who will introduce our speaker today.
Hello, everybody. Thank you all for coming. This is our 9th talk in 2020 in the Data Then and Now speaker series, which is co-hosted by eScience, the Information School, and Human-Centered Design Engineering. We're so pleased to be co-hosting this with the Data Science Seminar and that you all are here. I want to begin by acknowledging that there are people and students who are feeling a lot of pain right now. People are grieving as we confront not only the pandemic, but also the horrors of structural racism. So I'm really grateful to the students and other members of the UW community who are able to be with us today. We're so pleased to have Warren Sack virtually with us today. And though we're not all together in a lecture hall, I still want to start with a land acknowledgement. The University of Washington acknowledges the Coast Salish peoples of this borrowed land on which we stand, the land which touches the shared waters of all tribes and bands within the Duwamish, Suquamish, Tuliap, and Muckleshoot nations. We pay respect to elders past and present, as well as the living descendants and future generations of the Coast Salish. So we have the amazing Warren Sack here today. He is professor of film and digital media at University of California, Santa Cruz, as well as the chair of the film and digital media department. He is a media theorist, a software designer, and an artist. And he recently published an excellent book called The Software Arts, which retells the history of software, placing arts and humanities in the center of that story. And some of us read some selections for this book prior to Warren's visit and had a really lively conversation about it. I'd like to read an endorsement of The Software Arts from none other than Donna Haraway, who had this to say about the book. Warren Sack's creative thinking across the arts and sciences has kept my cyborg on her toes, provoked again and again to test out how to reinvent practices for thinking, designing, working, and playing together for less deadly worlds. Sack's historically attuned book investigates the folded zones linking the mechanical and liberal arts as new languages called programs have been built for emerging worlds. So hopefully that gives you some sense of where Warren's coming from, and I hope you all can read The Software Arts. We asked Warren to speak for 30 minutes, which leaves us a ton of time for questions. So please just enter your questions as they come up in the Q&A feature, and I will read them to Warren at the end. So I hope you all can join me in welcoming Warren Sack to University of Washington. Thank you.
Thank you so much for inviting me. It's really wonderful to be here. It took a lot of planning. I appreciate all the work that you have done, and it's really wonderful. I've had the opportunity earlier today to talk to a variety of you, and I apparently get to continue tomorrow. I am on the UC Santa Cruz campus, and I too would like to do a land acknowledgement. The land UCSC is built upon is the traditional and unceded territory of the UP tribe of the Awasawas Nation. Today, these lands are represented by the Ama Mutsun tribal band, who are the descendants of the Awasawas and Mutsun nations, whose ancestors were taken to Mission Santa Cruz and Mission San Juan Bautista during Spanish colonialization of the Central Coast. So I think this, I'm very glad of these land acknowledgements. We are changing to acknowledge the structural racism. And I too want to acknowledge that many people are in pain today. So it's an odd venue, these Zoom things, although we've all gotten used to them, I guess. It feels, nonetheless, it feels like what we're doing is what we do every day. And I think we need to believe in what we do in order to have a kind of regular event, if you will, in times like these. I'm going to talk about, today I'm going to talk about, the title is A History of the Demo and a Future for the Essay. And it intersects with my book project that I finished last year for the MIT Press Software Studies series. And, but we go off into a different direction with this. I'm specifically trying to think about how we make a point with a lot of the tools of data science and data visualization. So I start with a quote from the philosopher Hannah Arendt, who published The Human Condition in 1958. Her prologue begins with a passage on the first artificial satellite, which was the Sputnik 1, launched on October 4th, 1957 by the Soviet Union. And this was the beginning of the so-called space age, a zeitgeist I remember distinctly as a child of the 60s and 70s. But now, apparently, we're no longer in the space age. In the contemporary data age, our sights are not fixed on the stars, but on our social media feeds. The difference for technologists was wryly phrased by the entrepreneur, billionaire, and Trump supporter Peter Thiel. Quote, "We wanted flying cars, instead we got 140 characters." But if the data age is a technological disappointment, it's also a time of dysfunctional hallucination born of a lack of language. And Arendt phrases the language problem like this: "The trouble concerns the fact that the truths of modern scientific worldview, though they can be demonstrated in mathematical formulas and proved technologically, will no longer lend themselves to normal expression in speech and thought. It would be as though our brain, which constitutes the physical material condition of our thoughts, were unable to follow what we do, so that from now on, we would indeed need artificial machines to do our thinking and speaking." We now live with smartphones, machine learning, and artificial intelligence. Have we yielded our thinking to machines, as Arendt feared? Can we only demonstrate what we know in mathematical formulas and new technologies? Or can we take up the challenge she throws down to render the truths of today's world in normal expression of speech and thought? To take up this challenge is to engage in the struggle to see and to act within the politics of data and artificial intelligence. So the science fiction author Isaac Asimov wrote, "Any sufficiently advanced technology is indistinguishable from magic." Asimov offers a path of least resistance to Arendt's problem of rendering the truths of modern science in the normal expression of speech and thought. We can indeed conceptualize contemporary science and technology with the lexicon of magic, but what we do more frequently is examine these truths through science fiction. Think about all the science fiction novels and films you know that include artificial intelligence. The co-founder of the field of artificial intelligence, Marvin Minsky, was a consultant for Stanley Kubrick's classic 2001, A Space Odyssey, a film that is still compelling 50 years after its production. Minsky's advice infused the film with a social technical imaginary about the future of artificial intelligence that also drove the goals of AI researchers, aiming for machines capable of natural language dialogue, lip reading, self-diagnosis and repair, and planning for complex situations. Arendt can be answered by saying that the language of science fiction film allows us a language for discussing science and technology in normal discourse. But in good science fiction, it's frequently difficult to tell where the science ends and the fiction begins. We know there are no homicidal HALs inhabiting the space station, yet Apple's ads for Siri encourage us to imagine it as a knowledgeable dialogue partner, and even serious scientists like Stephen Hawking have told us that the singularity is approaching when a machine of superhuman intelligence will overtake us. So regardless of the accuracies of these kinds of prognostications for the future of AI, they only provide a partial answer to Arendt's challenge. How can we talk about the AI of today without making a bunch of guesses about the AI of tomorrow? For example, how do we discuss in a popular venue how Siri works and what it can do? Posed this way, an answer to the question immediately comes to mind. We might just call it anthropomorphization, where we relate to Siri as if it were a human. We think of it as a human-like assistant. At Apple, this vision of Siri as a human assistant precedes Siri. It goes back at least to the Knowledge Navigator concept video of 1987, in which a professor's computer is depicted as a bow-tied AI on his screen. Apple's video is a sort of demonstration of a seemingly possible future technology. And while I will not return in this talk to the Knowledge Navigator, I will return to the role of demonstrations or demos in software development and evaluation. Social science has a vocabulary for describing the natural tendency for us to anthropomorphize things and machines. AI researcher Douglas Hofstadter dubbed our tendency to think of software as if it were human the, quote, ELIZA effect. In her 1987 book, the anthropologist Lucy Suchman describes this tendency in her discussion of computer scientist Joseph Weizenbaum's computer program, ELIZA, the first chatbot that could be mistaken for a human. According to Suchman, projecting humanness onto a piece of software is explicable using what sociologist Karl Mannheim called in the 1920s the documentary method of interpretation, which was elaborated in the 1960s by the sociologist Harold Garfinkel as ethnomethods, a key concept in ethnomethodology, an approach to studying, among other things, the social side of computer technologies employed by many computer scientists and anthropologists today, such as Paul Durisch at Irvine or Genevieve Bell. More generally, we can call this approach ethnography, and so far as much of ethnomethodology can fit in the footprint of ethnography, where the subject of study is people's interactions and discourse. Nevertheless, neither is the ELIZA effect a complete answer to Arendt's question. While it is undeniably true that anthropomorphization is an ethnomethod, in other words, it's certainly true that most of us talk to our cars and our computers, at least sometimes, as if they were people or pets, it's only descriptive of how humans act. It's not descriptive of how software works, and certainly does not address how software ought to work. So I think neither the images of science fiction nor the concepts of ethnography address Arendt's challenge. Nevertheless, I want to acknowledge the very insightful research produced by ethnographers of data and algorithm, like Angèle Christin at Stanford, Tena Boucher at Oslo, and folks here at UW, like David. The ethnographers of data and algorithms, in concert with authors of a set of cultural critiques of algorithms and big data, like Cathy O'Neill, Weapons of Mass Destruction, Ruha Benjamin's Race After Technology, and Safiya Noble's Algorithms of Oppression, show very clearly how bias, discrimination, lack of accountability, and non-transparency are endemic to the software systems of today. Nevertheless, Arendt's challenge still stands in this age of AI and big data. Indulge me to repeat Arendt's articulation. Quote, "The truths of modern scientific worldview, though they can be demonstrated," and note that I'm emphasizing the word demonstrated, "in mathematical formulas and proved technologically, will no longer lend themselves to normal expression in speech and thought." So today, demonstrations of math and technology have a radically different form than they did in 1958 when Arendt wrote these words. I claim that studies of science fiction, cultural critiques of big data and AI, and ethnographic studies figure software as objects and subjects, but lose sight of the fact that software systems are also demonstrations. To address Arendt's challenge, one must examine how and why certain things can or cannot be demonstrated in mathematical formulas and proved technologically. So in short, algorithms are arguments, or that's my argument, and they're difficult to understand or argue against if they're not understood to be a form of rhetoric, a form that I call abductive demonstration. So Megan described my book, and in one of the chapters of the book, the topic is digital rhetoric. So Aristotle tells us that the strongest rhetoric is closely tied to logical demonstration. This chapter traces a history of rhetorical demonstration. The history of the demo starts in ancient Greece, when definitive demonstration was a matter of deduction as practiced in geometry. Euclid's demonstration, or deductive demonstration, is displaced by inductive demonstration in the 17th century during the scientific revolution. Inductive demonstration, let's call it Robert Boyle's demonstration, was made necessary when arguments began to be based on empirical data and not just derived from statements taken to be obviously true. Today, arguments are made on the basis of so much data, big data, that no one person could possibly read it all, much less observe its collection. This has necessitated the invention of yet another form of argumentation that I term abductive demonstration, or alternatively, Salmanov's and Kolmogorov's demonstration. The latest form of rhetorical demonstration is actually a kind of data compression that is otherwise known as machine learning. And my point is concordant with media theorist Jonathan Stern's idea that we should now be concerned with compression rather than representation. One could say that the founding document of contemporary machine learning was Ray Salmanov's 1960 publication, A Preliminary Report on a General Theory of Inductive Inference. Employing a theorem in Salmanov's paper, Soviet mathematician Andrei Kolmogorov articulated a theory of complexity. The Kolmogorov measure of complexity, or randomness of a collection of data, is the length of the shortest computer program that can generate the data as output. Machine learning algorithms are designed to accept a collection of data, search the space of computer programs to find the shortest one that is applicable. We're meant to believe that big data sets are aptly characterized by the outputs produced by machine learning algorithms, but we have no way of checking the data. So I call this an abductive demonstration because Charles Peirce, who first articulated abduction in its contemporary sense, said that abduction is a form of interpretation or guessing. Or we might say that abduction is a practice well known to the arts and the humanities, if we term it politely as interpretation. The chapter in the book proceeds from the older means of making a point to the newest forms of persuasion. And I hope the reader, to provide the reader with ways to both question and compose software arguments. So to show what these arguments look like, I'm going to focus today on Google Translate in particular and machine translation more generally. Machine translation is one of the oldest items on artificial intelligence's research agenda. And today it's considered by many to be a grand success due to methods of big data and machine learning. And I want to highlight specifically the discursive resources that can be brought to bear to argue for or against the big data algorithms of machine translation. In other words, what convinces us that Google Translate works? So over a decade ago, Wired magazine editor Chris Anderson announced that the scientific method is obsolete because theories and models were no longer necessary in the current age of big data. He points to, among other things, Google's online translation service that seems to work with neither a model nor a theory of language, translation, or meaning. Anderson's argument pivots on what he takes as a given, that Google Translate works. But I will argue that Google Translate is incompetent when measured as we might evaluate the skill of a human translator. The inner workings of Google Translate are the result of an artificial intelligence process, specifically a machine learning algorithm, applied to a vast amount of data, most of it inaccessible because the majority of the data is proprietary to Google. The result itself is vast. It's essentially a multi-billion term polynomial that is so large, no one could ever read it. So we're talking, just x plus y plus z, a weighted polynomial. That's the sort of canonical form of a neural network. Arguably, it is neither a model nor a theory since it's too large to be read, much less understood. Yet according to Anderson, it's supposed to be better than a model or a theory because it works so well. But actually it does not work. Its construction can never be replicated because the data was built from, cannot be shared with anyone outside of Google. And the inner workings of the translation system are so large that no one could ever read them. So this is just one example of the plight of theories, models, and methods in the age of big data. But it's an important example, if only because ever since Warren Weaver, one of the co-founders of information theory, proposed in 1949 the idea that computers could be programmed to translate text from one language to another. And since then, machine translation has been central to the discussion of what computers can or cannot do. A few years ago, in 2016, Google completely rewrote its translation system using some new techniques from machine learning. The Google software engineers responsible for this published a series of papers on the overhaul, including one titled, quote, Google's multilingual neural machine translation system enabling zero-shot translation. In that paper, the Google researchers described how they trained their machine learning algorithm on hundreds of millions of sentence pairs, like the English and French pair, to be or not to be, that is the question, être ou ne pas être, telle est la question. The amount of computation necessary for the machine learning was extraordinary. Depending on the number of languages, a full training can take up to 10 million steps and 3 weeks to converge on roughly 100 GPUs, as the lead author tells us. For those of us who are not machine learning experts, it's equally striking that the quality of translations that are produced by the resulting system is not scored by humans, but instead evaluated automatically by using a small computer program, which you can easily get at right here. It's a little piece of Perl, 175 lines. So consequently, even if their neural network machine learning algorithm can properly be called inductive, the Google's author's demonstration is nevertheless abductive in the sense described by Charles Peirce. First, because no human can follow what's being done step by step and 100 GPUs over the course of 3 weeks. And second, because relative to the demonstration, no human ever sees more than the tiniest sliver of translations done by the machine. And symptomatic of this is that only about 20 example translations are presented in the text of the paper. And all of them are translations of these 4 English sentences. 1, hello, how are you? 2, I wonder what they'll do next. 3, I must be getting somewhere near the center of the earth. 4, here the guinea pig cheered and was suppressed. This, it seems to me, is a curious choice of examples, but most pertinent to my assertion that the paper performs an abductive demonstration is the fact that only 4 source sentences are presented, even though the data set would have allowed, in principle, hundreds of millions to be presented for inspection. The visual diagrams of the article further underline its abductive character. The visualizations presented are colored network diagrams that look approximately like a plate of spaghetti with some colored marbles thrown in. The authors assert that the diagrams represent, quote, 74 triples of semantically identical cross-language phrases. That is, they continue, each triple contained phrases in English, Japanese, and Korean with the same underlying meaning, unquote. Despite the fact that there seems to be no obvious way to interpret these diagrams as meaning one thing or another, and despite the fact that the sample chosen of 74 sentences is again only a tiny sliver of the hundreds of millions of examples the authors used as data, the authors nevertheless conclude the following about their spaghetti and marbles diagrams. Quote, visual interpretation of the results shows that these models learn a form of interlingua representation for the multilingual model between all involved language pairs. This conclusion seems to me to be a case of what the artist and philosopher Hito Steyerl has diagnosed as data apophenia, that is, imaginatively seeing things in the data. So does Google's translation software, both the code and technical papers, represent an abductive argument? I think so, because it's so big, the software system itself could never be read by any one person in a lifetime. In the technical papers describing it, almost none of the steps taken to produce the software are shown because there are so many steps, and almost none of the data analyzed is shared because it's owned by Google. Consequently, and not only because the machine learning algorithm requires hundreds of computers to run for weeks to achieve the claimed results, Google's results cannot be reproduced by anyone outside of Google. So what this example should make clear is that the abductive demonstrations of big data and machine learning algorithms are quite unlike the inductive demonstrations of science. If inductive demonstrations, we are given the data, shown step by step how it was gathered, and even invited to witness its gathering. Inductive demonstrations of science prove or disprove a hypothesis. Abductive demonstrations of big data do not start with the hypothesis. Instead, an effort is made to correlate every variable with every other variable and output any correlations that are above some threshold. In science, we're careful to avoid fishing expeditions in which correlations might be found simply because we try to correlate too many variables. In data science, fishing expeditions are the norm. The big question for abductive demonstration is whether or not the resultant statistical model works, or in the words of Google Director of Research, Peter Norvig, quote, engineering success shows something is working right. So because Google's translation system is such a different animal than the usual production of science, it's impossible to use the usual tools of science to question the result by, for instance, examining the data, witnessing its gathering, attempting to reproduce the result, or even closely reading the model. Instead, we can follow Norvik's suggestion that we examine whether or not it works. So this is the point here. In this literature, in this era, if you will, of big data, we have a set of arguments coming at us, a set of demonstrations coming at us that are of this abductive form. And the question is, what can I do if I don't own a Google? How can I argue like for or against this? Norvig, the head of Google's research, gives us an answer. He says, well, see if it works. So does Google Translate work? I claim that anyone who is literate in 2 or more languages can easily see that Google's service fails miserably as a translator. Sure, it helps with spelling and conjugations, but it does not do the work of a translator. I'm very willing to yield that. I use it all the time, but I don't use it as a translator. I use it like a dictionary. By calling its website a translation service, Google is engaging in what artificial intelligence researcher Drew McDermott, in his essay, Artificial Intelligence Meets Natural Stupidity, calls wishful mnemonics. So it only takes a couple of examples to show that Google's service makes mistakes that no novice translator would likely ever make. In a 2018 essay written for The Atlantic, AI researcher Douglas Hofstadter illustrates the weaknesses of Google Translate by testing the system with some sentences in French, German, and Chinese. And I'll follow Hofstadter's rhetorical approach, but not as exact examples. Inputting the following 2 sentences and requesting a translation from English into French yields the next 2 sentences. So I input, I park the car next to John's house. If it is still there, you can you drive it back to my place? And the output, j'ai garé la voiture à côté de la maison de John. S'il est toujours là, pouvez-vous le ramener chez moi? So in French, here's the problem. In French, the noun for car, voiture, is gendered feminine. So to refer to it with a pronoun requires the use of elle or la, and not il or le, as Google does, which are masculine pronouns, il and le. A French speaker would read the second sentence that includes il and le without any clear understanding of what the le refers to. One might infer that the il refers to John, since the name is masculine, and therefore the speaker-writer is telling us that John is still there at his house and that he'd like the recipient of the message to bring John back to the speaker's house. Now that's obviously not what the meaning of the English is. In English, he wants the car to come back to his house. He doesn't want John to come back to his house, right? So I could provide you with more example of Google Translate's dysfunction, but even with only this example, we can see a major cause of its errors. The software has not been trained to infer connections between sentences, and so errors like we see here are almost inevitable. Reading Google's technical papers corroborates this diagnosis and provides us with an even more detailed exposition of the designer's theoretical and methodological commitments. Google researchers described how they trained their machine learning algorithms on hundreds of millions of sentence pairs. Thus, the translation software is trained to work on a sentence-by-sentence basis. And knowing this, we're very quickly disabused of any notion that Google Translate is recognizing a line from Shakespeare's Hamlet. Google Translate does not consider the many distinguished human translators that have rendered this sentence into French many times over the last several centuries. Neither does Google Translate ponder why, while Shakespeare's lines are predominantly written in iambic pentameter, this particular line has 11 syllables. So what is the poetic purpose performed by 11 syllables rather than 10? And should the French translation also have 11 syllables? Google Translate does not go there, right? So in linguistics, there is a general term for the connections made between sentences, between one text and another body of text, that is between, for example, an isolated sentence and a play or a larger body of work produced by Shakespeare. And this general term is cohesion. Although cases of cohesion, like anaphoric reference, matching pronouns to proper nouns, have been addressed in previous work in computational linguistics, in the newest machine learning algorithms that depend upon millions and millions of examples, the previous work cannot be taken into account. And consequently, we can diagnose Google Translate's dysfunction as errors of cohesion, or more generally as a core technical problem known for the last 60 years of AI research as the lack of context or common sense. And this common sense problem has inspired decades of efforts to try to encode all of common sense into a database, a quixotic effort destined to fail, I believe. This is Douglas Lynott, who's been coding psych database of common sense knowledge for decades with a huge team. So early this century, artist designer Sawad Brooks and I began our translation map project to demonstrate an alternative to black box translation systems like Google Translate. And in 2003, it was exhibited as an art project curated by Steve Dietz at the Walker Art Center in Minneapolis. And in our proposal for the commission, we cited Walter Benjamin to describe what we wanted to make, what kind of a translator we wanted to make. And we cited Warren Weaver, this image we've already seen, to describe what we did not want. So Warren Weaver's 1949 essay on translation is both a serious technical proposal, arguably the document that launched the entire field of machine translation, and it is also a fantastical, delirious thing that at its most outrageous sounds like this. When I look at an article in Russian, I say, this is really written in English, but it has been coded in some strange symbols. I will now proceed to decode. Arguably, Google Translate is an offspring of Weaver's delirium, if we follow the genealogy of the specific technologies that are employed in Google Translate. So in contrast with the translation map, an author can write a message in one language and send it to arrive at a specific geographical region in a different language. For example, I might send a message written in English to arrive in the Democratic Republic of Congo in a local language like Luba Kasai. A wiki-like interface is provided so messages can be composed in small pieces. These small pieces are then routed through a series of online public discussions tagged with a request to bilinguals to help translate some of the message and then forward it on. One can think of it as a kind of packet switching network where helpful bilinguals translate packets along the way until the full message arrives at a public forum in the destination composed in the target language. So in short, the translation map is intended to support translation as a collaborative human effort and not as a black box machine. The smarts of the system, if one can say there are any, reside in a large database about thousands of languages spoken in the world, the relations to one another, the hundreds of countries and other geographical areas, and the relations, a set of assertions about which languages are spoken where, and a database of public discussion groups associated with the specific geographical areas. And this allowed the translation map to compute routes between languages and regions. So for example, the translation map determines that no country in its database exists in which English and Luba Kasai are both spoken. So it searches for a third language, a bridging language, a language through which English and Luba Kasai can be connected. The first language found that meets these criteria is French. The translation map finds in its database that the DRC was the private property of the King of Belgium, and that English and French are spoken in Belgium, and French and Luba Kasai are spoken in the DRC. And thus the translation map proposes that the message might first be routed through Belgium to get it translated into French, and then sent on to the DRC to be translated from French into Luba Kasai. And the author of the message can pick one of the proposed routes. So the system provided a web-based interface, a wiki-like system for composing, editing, and translating messages, a router for connecting languages and countries, and even a message formatter to allow messages to be output and folded. So I was surprised when the art critic of the New York Times wrote that it did not work. Quote, the best work in translocations, an online exhibition of 9 new internet-based artworks presented by the Walker Art Center in Minneapolis, succeeds aesthetically because it's destined to fail electronically. Translation Map, one of the works, allows viewers to write and send email to any of 250 countries. There is just one problem. The internet is considered a global village that inspires free-flowing conversations, but few of these messages will ever be received. Translation Map by Warren Sack and Sawad Brooks argues against the internet's utopian promise. The work's achievement is to show just how disconnected parts of the online world still are. So I was pleased that the art critic understood the Translation Map to be enacting an argument. And once I thought about it for a while, his charge that it was, quote, destined to fail electronically was not so surprising. At least since the philosopher Immanuel Kant, the notion that art should have neither purpose nor practical function has been a tenet of conventional aesthetics. There are thus problems with Norvig's question. Peter Norvig, the head of, the director of research at Google. His question is, does it work? One is presupposed by the art critic of the New York Times. If it's art, then according to conventional aesthetics, it does not or it should not work. This analysis of working software in the art world reveals a risk for software designers in the art world and elsewhere, namely in certain institutional contexts, the software may be said not to work, even if one can argue that it does work. And we see this institutional framing functioning in reverse for Google Translate. Even though Google Translate obviously does not work as a translator, practically everyone assumes that it does work. So I hope this case illustrates the software of the Translation Map can be read as an argument against and alternative to the software, that is the code in the technical papers of Google Translate. Or more generally, my point is this: algorithms can be arguments, and we can use software essays like the Translation Map as a means to object to and provide alternatives for the automations and digitizations we're being asked to suffer or ignore. And that's all I have to say today. Thank you.
Yay, thank you.
Thanks,
Thanks
Warren.
so much.